Imagine this. The Earth is thriving with life, bustling cities, and technological marvels. But above us lies the vast expanse of space, silent and mysterious. Here's the question. Why is it that nations worldwide abide by a near-universal rule? No nuclear explosions in space. Could it simply be a political agreement, or is there something far deeper at play? Simulation theory suggests that our universe is a highly advanced digital construct, a simulation designed with rules to maintain stability and coherence. Within this framework, the ban on nuclear explosions in space may not be about international treaties or environmental safety. Instead, it could be a system safeguard, a rule coded into the simulation to prevent catastrophic errors. Consider this. Nuclear explosions release immense energy, disrupt electromagnetic fields, and could potentially interfere with the very fabric of the simulated universe. Could they expose the simulation's underlying code, or even cause glitches in reality? In this video, we'll delve into the intersection of nuclear technology, space exploration, and simulation theory. By the end, you'll have a fresh perspective on why this global prohibition exists and what it might reveal about the nature of our reality. But stay with us, because as we uncover the reasons behind this mystery, the answers will challenge everything you think you know about the universe. Simulation theory has captured the imagination of scientists, philosophers, and thinkers worldwide. It posits that our reality is not the real world, but a digital simulation created by a super-advanced civilization. Everything we perceive, from the laws of physics to the flow of time, is part of this program system. But like any simulation, there are rules, boundaries, and safeguards designed to ensure the system functions smoothly. One fascinating intersection of these ideas lies in humanity's exploration of space. In the 20th century, during the height of the nuclear arms race, nations conducted nuclear tests underground, underwater, and even in the atmosphere. But when it came to space, a universal agreement emerged. No nuclear explosions beyond Earth's atmosphere. The Outer Space Treaty of 1967 formalized this ban, but its origins raise intriguing questions. Was this decision driven solely by political and environmental concerns, or was there something else guiding it? Within simulation theory, this prohibition takes on a new dimension. If our universe operates like a programmed system, nuclear explosions in space could pose a unique threat to the simulation's integrity. Unlike explosions on Earth, which are contained within specific parameters, a nuclear detonation in the vacuum of space might disrupt the system on a larger scale. Could it reveal the code underlying reality? Could it destabilize the simulation, creating ripples that extend far beyond our planet? In the next section, we'll explore the challenges and mysteries surrounding this prohibition, shedding light on why nuclear explosions in space might be more than just a geopolitical concern. The prohibition of nuclear explosions in space presents a fascinating mystery. On the surface, it seems straightforward. Such explosions could pose environmental risks, disrupt satellites, and endanger astronauts. But when you dig deeper, the questions start to multiply. Why has this rule persisted so universally? What makes space so different from other environments where nuclear testing occurred? One theory is rooted in the nature of space itself. Unlike Earth, space is a vacuum, and nuclear explosions behave differently in such an environment. Instead of being contained by the atmosphere, the energy from a nuclear blast spreads out, creating massive electromagnetic pulses and high-energy radiation that could potentially interact with the underlying structure of reality. In the framework of simulation theory, these interactions might disrupt the programming that governs the universe. There's also the question of evidence. Historical experiments like the U.S. Starfish Prime Test in 1962 showed that nuclear explosions in space could create artificial radiation belts and disrupt global communications. But some theorists argue that these tests might have revealed something even more startling, anomalies that hinted at the simulation's underlying framework. Could these anomalies explain why humanity collectively agreed to halt such tests? Finally, consider the psychological dimension. If we live in a simulation, those who control it might have programmed subtle safeguards to prevent us from probing too deeply. The prohibition on nuclear explosions in space might be one of these safeguards, designed to steer humanity away from actions that could expose the system. In the next section, we'll delve deeper into the evidence and theories that connect simulation theory to this fascinating topic. To understand why nuclear explosions in space might be forbidden within a simulation, we need to examine three key aspects: historical events, scientific implications, and theoretical possibilities. The Starfish Prime test of 1962 is a pivotal moment in the history of nuclear testing. When a 1.4 megaton bomb was detonated in space, the results were unprecedented. The explosion created artificial auroras, visible for thousands of miles, and knocked out electronics in Hawaii, hundreds of miles away. Some accounts even suggest unexplained phenomena occurred, such as unusual fluctuations in radiation levels and disruptions to communication systems. Could these anomalies have hinted at the simulation's boundaries? Nuclear explosions in space release immense energy, including electromagnetic pulses that can travel vast distances. These pulses could theoretically interfere with the simulation's data streams or create glitches in its programming. In the vacuum of space, where the laws of physics behave differently, such disruptions might be magnified. Simulation theory suggests that these glitches could destabilize the system, leading to unpredictable consequences. If our universe is a simulation, the prohibition on nuclear explosions in space might be a form of patch implemented by the system's creators. Just as software developers design programs to prevent users from accessing sensitive areas, the simulation might include safeguards to prevent us from inadvertently disrupting its architecture. Nuclear explosions in space could be one such action, a step too far that risks exposing the system's code. In the next section, we'll explore the implications of this idea and what it might reveal about the nature of reality. Here's the breakthrough. Nuclear explosions in space might not just be prohibited for safety reasons. They could represent a direct threat to the integrity of the simulation itself. Imagine this. A nuclear detonation releases a surge of energy that interacts with the simulation's code, creating a ripple effect that destabilizes reality. This isn't just science fiction. It's a logical extension of the simulation theory framework. Some theorists propose that the anomalies observed during historical tests were early warnings. These disruptions could have revealed glimpses of the underlying system, prompting those in power to establish a global ban. If simulation theory is correct, the prohibition isn't just a political or scientific decision, it's a necessity to maintain the illusion of reality. But what does this mean for us? If there are rules we're not allowed to break, what other safeguards might exist? And who, or what, enforces them? As we explore these questions, we'll uncover new insights into the simulation and our place within it. The prohibition on nuclear explosions in space isn't just a geopolitical or environmental issue. It's a clue to the nature of our reality. Simulation theory offers a compelling explanation for why this rule exists. It's a safeguard designed to protect the integrity of the system. From historical anomalies to the scientific implications of electromagnetic pulses, the evidence points to a deeper mystery. If we live in a simulation, then every rule, law, and prohibition might serve a purpose beyond our understanding. The ban on nuclear explosions in space could be one such rule, a boundary designed to keep us from probing too deeply into the nature of reality. But this is just the beginning. What other mysteries might simulation theory explain? And how can we begin to uncover the secrets of the universe? What do you think? Is the prohibition on nuclear explosions in space just a safety measure? Or could it be evidence of something much larger? Share your thoughts in the comments. We'd love to hear your perspective. If you enjoyed this deep dive into simulation theory, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an upload. And if you're curious about other mysteries, check out our other videos. Thank you for watching.